Hello, and welcome back to Learning with Lee. In the previous episode, we examined the copy constructor, as well as then the assignment operator. And in today's episode, we're going to continue that discussion by examining how to do those in a polymorphic manner. And since we don't really have anything involving linked lists or links that happens to be involving inheritance, we're going to discard those for now and just leave those alone, and focus instead on item. And in particular, let's start off with the copy constructor. And one of the key things about the copy constructor is that constructors cannot be made virtual. It's important to remember that we do end up calling our parent's constructor in somewhere like this, so we can do something somewhat similar. So let's start off with item. And for this, we're just going to go with a default copy constructor. All it's going to do is it's just going to take in another, and in this case here, I'm actually going to, well, we could either go with a pointer to an item or a reference to an item. Let's just go with a reference to an item for the copy constructor for now. We can just call this item I. Relatively easy, relatively simple. Head on over here. Do that. And then all we're going to do in here is we're just going to take these and convert them so that now, rather than using whatever arguments we were passed in, we just use I's equipped version of them. So we can just do things like I._name and then get rid of all that, as well as then I._weight, and so on and so forth down this little line here. Oh yes, and right now it's giving me an error because oh no, that's not why it's giving me an error. Oh, it's giving me an error because I don't have the namespace or the class name in front of it. So there's that. That fixes all that. Except right now it currently is complaining because, oh, I didn't save this. Okay, do that. Then this fixes itself. And that's really all you have to do for your default copy constructor here. So the question then is how to do this in a polymorphic manner. Well, there's a certain amount of limitations in terms of how you can do it for copy constructors, because when you're constructing something like this, you end up needing to actually use whatever type it is. So what you would then do down here is you go, okay, I want a weapon, and I want it to take in another weapon. We'll call this one W. Once again, just for simplicity's sake, do that. Oh yeah, save this so that we don't have to deal with any of the errors that we were getting on that other one. And get the namespace correct. And then we can just copy over directly, basically, all of these rather than as arguments in here. And the major thing is that the way in which this ends up becoming somewhat polymorphic is that what we're going to do here is, if we head up here, and I do this, and I then call into item, and I just, in the same way that I did the other one, just so we're consistent about it, I can just then pass in W. Because W, since it's a weapon, is of type item, and it'll effectively be converted to there. Oh yes, and we'll actually want to do this by reference, just so as that then what we can end up doing is that otherwise it ends up copying it around, which could lead to some problems in terms of how it gets copied into here. And one of the important things to understand is that if I, let's say in here right now, let's say that I had, and let's just create up here, weapon W and have it equal to a new weapon. And I did that, and then over here I did item I and I have it equal to W. What's going to end up happening with this, and the reason why this is a bug is because of the fact that it's not in this form, but what's going to end up happening here is that the fields that are in W that are also an item, so basically it's going to convert W into an item and copy those fields over automatically. It's going to do a shallow copy like I mentioned in the previous episode, so it does have some problems. Fortunately in this case here, most of this is relatively safe and stable. I mean, for strings, that might possibly cause a problem. However, it shouldn't, since we're dealing with strings themselves and not dealing with string pointers or string references. But in case we were, then we would have to manually create the memory to store those. But for now, it will actually do the copying for us correctly, just like it would on any of these basic types. So what it'll do here is it'll copy all the stuff that's an item, and it'll discard the stuff that is in weapon in this version here. It's not going to basically treat this as that. In case I did this equals the address of that, then it would actually be a weapon stored in item, because the pointer doesn't really matter. It's not going to modify any of that data. Unfortunately, right now it's not copying anything. And in case I also did something like weapon w2 equals w, that would also end up giving us a shallow copy. However, in order to get it to be a deep copy, let's get into now how we're going to be dealing with this operator here and make certain that we do that correctly. So I'll just change this back to this so that actually works some. And then over in, well, let's start with item. So we can actually make our functions virtual for doing operators. So virtual, and we'll just say this returns an item pointer. And there's a reason why I'm going with pointers. So we want it to be an operator equals. We want it to take in an item pointer, and we just call it I once again. So we're just going to take that, put that down here. Once again, need to add in our namespace, because C++ is mildly annoying in that way. Not really something that you need to do in Java or C#, but it's a good thing to be aware of in this case here. Oh yeah, and we don't need virtual. Virtual just is something that we include in the header, similar to how, if you remember how static would give us errors in case I tried to include it over in here. So we have that. Oh wait, there's the problem. Yeah, put item in the wrong spot for this, so let's just copy that guy over here. And then that'll fix that error there, except it's not returning anything, so return I. And what we then want to do is we want to then copy from one to the other. So we can just take this, and it's just going to be a simple set of changes of rather than using these dots, we use the arrows. So quickly change all of these, and this really happens to be nothing too significant in case we had anything that we need to really deep copy, such as in case we needed to deep copy name for whatever reason. We could end up doing some stuff with that, but that's something to really consider further on down the line. For now, let's just look at the general problem that we then run into. So we have this virtual operator here. So if we want to override that in weapon, so as that then in case, let's say I have some weapon, and we'll just call this w2, and it is equal to a new, well, for now, we're just going to do w2, and then we just do that. What we're then going to do is we're going to say, so we have some item pointer I in order to demonstrate how we would get into this situation. And we have that equal to w2. So what we then do is we do I, or more accurately, we're going to dereference I. So don't even really need the parentheses there. There's that, and we have it equal to w. So is that whatever is pointed to by I, in this case here w2, equals w. Except we're doing it at the item level. So right now, what you would immediately think is that, okay, this is going to go in and it's going to use this operator here. However, the way in which we can then get this to be polymorphic is we can override that in here. However, then the problem is that, okay, well, what are we looking to do? We need to do this, basically, in order to properly override it. So it's taking in an item pointer. And there's the reason why I chose a pointer, is that we're going to need to be able to convert this pointer into whatever type of pointer we actually need. So if it's a weapon, such as in this case here, we're going to want to have special logic if we're dealing with a weapon. Otherwise, we're just going to want to copy whatever's in, basically use our base class's version of that, so item's version of this operator in here to do that. So what we then do in here is we just take this, once again, add in our namespace as is appropriate in here, and then down in here, we're going to have to add in some checks to make certain that we're actually in a weapon. So first off, we can just return I, because that's easy enough, and that prevents any of the errors. One of the other things that we're going to want to do is how you actually call into your parent class or your base class's version of this same item. And this is what you do. You use the name of your base class, name of your parent class, then the double colon to signify you want its namespace, and then you do operator equals, and you do this. And effectively, it's treating it as though you still are in this same scope of your current object, of basically the current weapon, except that you're able to then basically go, I want to do this as though I were my parent, not me. So this is how you end up actually accessing your parent's version of a virtual method or virtual function. And then what we would then have to do is we'd have to check that the item that we get passed in is in fact a weapon. So how are we going to do that? And that's going to lead us to a somewhat important distinction between several different ways in which we can do this. The classical way that this would be done using what are known as enumerations. And you'll see up here how I have enumerations here. I forget if I've covered them already a bit in an earlier episode. But basically what an enumeration is it's a list of some items that in human readable name. And the important thing is that these aren't what's actually stored in memory. It doesn't store them as unknown and bashing. It doesn't store those strings in memory. What it can do, if I don't include this here, is it will automatically determine some value for each one of these, and it will just use that, and it basically uses some underlying thing, usually something like a character or an int, in order to represent each one of these individually. In this case here, though, because I had equals 0, and that just is to guarantee a certain starting point, it would go 0, 1, 2, 3, 4, 5, and 6. So it's a matter of, I could also then do, if I did equals 999 over here for magic, then this would be 999, this would be 1000, this would be 1001, even though it starts at 0 and goes to 1, 2, 3. And as such, that's really about all I'm going to cover with enumerations for now. But the more classical C way of doing it is to have an enumeration in somewhere like item, in which I would then go, okay, I want this to be a protected enumeration so that only item and its children can use it. So we're going to go with enum, and we can call this one, I don't know, let's go item type, as this is a fairly common way of doing it. And then within here, oh yeah, we need to put a semicolon at the end. And the semicolon after the closing scope is a very common C practice, not really C++ or C# or Java. So it sort of is more of a legacy thing that is still done in C++ because it's so closely related to C. So in here I could have things such as item, weapon, armor, and then you put a comma after each item, well, after each element in your enumeration, and you just continue on. So we could have those in there, and then we could have something within each one of these, some form of either. Basically what we would probably do is we would go with some virtual function. So in case the enum's protected, we don't want to have that be a public method, since that would be exposing an enumeration that nothing else could actually use. We could go with, in here, virtual, oh yeah, and let's actually put after our enumeration so that it actually knows about it, because as this is still closely related to C, the order in which you declare things does matter. If I try to use item type before I've declared it, it can give me errors. So we'll just call this one get item type. And, oh yeah, and what it's going to return is it's going to return an item type. And we can just say, by default, it's just going to return, and within here, item type, and you can do basically this to get item. And there's how we would end up doing that, and then we could override it in something like weapon, in which down in its protected, we have this, and then it returns weapon. And we could then, over here, just do a simple comparison of if and we want its get item type, and then we want to check whether its item type is equal to the type of weapon, basically equal to a weapon, same type as this one is, or alternatively, we could do something along the lines of get item type here, so that we don't have to compare a specific version, but this current object's version. However, this leads us to a problem. And that problem is that, let us suppose that I is of type melee weapon, and its get item type returns melee weapon, not weapon. As a result, this current comparison is going to be false, because it's going to compare and it's going to get weapon back from this one, and melee weapon back from I's one. So you'd have to basically end up adding in another check and then make this one here specifically for melee weapon, as well as for all of these things down this particular pathway here. Unfortunately, that gives us a couple problems. That means that for every single type that we want, we have to create an entry not only in our enumeration, but we have to update every one of its parents to check for that type also. So we'd have to add in a check here. In case we had to this one's parent over in item.cpp, we'd have to add for the check in there in order to make certain that its types are correct. Or alternatively, we wouldn't actually have to do it here, but let's say that off of melee weapon we had spears or polearms. as their own specific subcategory of melee weapons. What we'd then have to do is that in melee weapon, we'd have to check for spears, and in weapon, we'd also have to check for spears in addition to melee weapons, because we could have those sort of problems. And you can see how this sort of cascades and grows out of control rather rapidly. And it's because of that problem, there happens to be something in C++ specifically to deal with that. And I'm going to get into that solution in the next episode so that we don't even have to deal with all of that stuff. Feel free to spend a bit of time experimenting around with this, try implementing it on your own, and see how it works out for you. That's really all that we have for today, so thank you very much for watching. Have a wonderful day.